My name is Callum and this is my engineering design project 2 presentation. Firstly, the contents page, we have the background, construction and operation, core development, the 7 weekly challenges, some additional features and some ideas for the future. Firstly, the EV3 brick. It's a Lego EV3 brick. The sensors and motors have preset functions which made programming really easy, and there's also a display that we can print the sensor values to, which made programming easy again. The two types of motors we used were the big motors and the medium motors. The two big motors we used to move the robot, and the medium motor was used for the gripper. The big motors do have encoders, and then to go on to the sensors, we have the gyro sensor, the ultrasonic sensor and the colour sensor that we used. So for construction and operation, there was 2 designs I did. I did a design using a gearing system to increase speed. So the robot here had a 765 RPM at this cog, the mini cog, which controlled the wheels. However, this did reduce the torque to 3.46 newtons per centimetre. However, with my final design I went with, it's a much better design as it's lower, it's more compact, it's stable. The wheels were attached directly to the motors, so providing 153 RPM, which is slower. However, it provides a 17.3 newton per centimetre torque, which is much higher and much better for pushing and moving objects. Also, the sensors were able to be used in the final design, but not this design because it was much closer to the ground. So for code development, the 3 types I used were flowcharts, as you can see here. For me, they were simple, broke down into the individual sections, and they're really easy to understand. Then I also used state charts, which again is simple. Each state is a different function set up basically. And then I also use bottom-up design. So basically you break down the programs and you build them function by function, and once you've got your basic functions, it's easy to change them into bigger and more complex programs. They're modular, so it's really easy to fault find and build the programs. The weekly challenges, just quickly, to do the first weekly challenge, the diameter, we used the diameter of the wheel, which was 5.6 centimetres, times that pi to get the circumference, divided 100, which is a metre, by the circumference to get how many rotations, and times that by how many ticks of the encoder to work out that doing a metre was 2046 ticks of the encoder. For the week 2, there was multiple challenges. The outcomes, so for moving forward 2 rotations, it moved 35.2 centimetres. For moving forward 90 degrees, it was 4.4 centimetres. For moving forward for 2 seconds, it was 63.7 centimetres. And for the following task, it was move forward 5 rotations and back 1800 ticks. So it returned to the start position because 5 times 360 is 1800, so it was the same back as it was forward. And then for the gyro, it turned between 358 and 360 degrees because the gyro sensor was not the most accurate. We'll get a bit further onto the rest as we go on. So for the week 1, as you can see, 2046 ticks, so once that was reached, both motors would stop. For the week 2, as you can see, the different separate functions, so for moving and turning, the gyro one here, and then just in the main, I just ran each function with a 1 second delay in between them. For the week 3, this was to do the maze. Again, it was similar to the previous task. It was just using the encoders and the gyro to move forward, so the individual functions, and then within the main it moves forward and then turns. So week 5 was to use the ultrasonic sensor. So up here you set up how far you want it to be from the object. This uses it to move forward, and then if it gets too close it'll move back until it's bang on 7 and then it'll stop. So for the week 6, this was the line following challenge. So up here we've got the calibration, which basically gets an average of the colours that the robot's on after it does a spin. This is good because if you use the robot in different environments, you can still use the same program. And then this part basically compares the value being recorded by the sensor, by the colour sensor, compares it to the average, and then it changes the motor speed to correct it and get it back online. If it can't find the line, it'll display to the text line to the EV3 brick I'm lost. sounds an alarm and moves both the motors back until it finds the line, or for 2 seconds as it were. And then for week 7, we have a function here to escape, but basically it'll move forward until it detects a red surface, and then when it does, it'll go up into here and say red surface detected on the screen. It'll sound an alarm, and then it'll move both motors forward until it gets off of that, and then it'll repeat that, and it'll move forward until it finds a red surface again. So some additional features that we made, as you can see in the image a bit further back, was a transportation system. So it moves items around an area. It was really cheap to add. It used one of the motors that we already had and a gripper. However, it can only carry light objects. But with the higher torque, it can push objects that are held in place. The gearing system that I added, we had gears for speed and gears for torque. However, if you do make it go faster or make it go have more torque, it negatively affects the other, so higher speed is less torque and vice versa. So we did go with no gears. And some ideas for future development: the line following it could be a bit smoother, and then when it was correcting and returning to the line, sometimes it wouldn't find the line properly, so that could be improved. The gyro sensors were a bit iffy, but if we used them, it's called sensor fusion, if we use them together along with the encoders, and got an average from both of the sensor values, then that would give us a more accurate degree or angle it would turn at. And then finish off the Mars rover project, so it'd search an area, and then it'd grab blocks and return to a safe area. It'd be good to do this because we've got quite a bit of code towards it. The only code we need to find would be to search a certain area and then grab the blocks and return to a safe area. But thank you.